So let's read what we've got to do with question 3a. We've got to find the probability that a randomly chosen strip of metal can be used. So I'm going to highlight some key information. First of all, we've got our standard deviation there. But what I don't see is I don't see a mu anywhere. So because we haven't got a mu, I'm going to put a question mark about that. That's giving me a clue that we're probably going to need to use a Z distribution. Now the next key bits of information are going to help us when we're going to produce our normal curve. It says 2.5% of the cut lengths exceed 50.98 centimetres. So I'm going to use that now and I'm going to create a normal curve. Now if you look on this normal distribution curve, I've marked here at the top end that 2.5% of the strips exceed our length. So that means 97.5% must be below that. So that equates to a p-value of 0.975. So I'm just going to write that in there, 0.975. Now I mentioned before we're going to be using the Z distribution because we weren't given mu in the question. So this distribution here has got our mu as 0 and our standard deviation as 1. So we're now going to use the class whiz calculator because I want to find this Z value here, and I'm eventually going to put that value into this equation here to find mu. So with the class whiz calculator, we want to use menu 7. And this time it's the inverse normal that we want to use. Now, I know that the area under the curve, it was that p-value of 0.975. So 0.975, press equals, and I've got already, this is for the standard distribution, so I've got sigma is 1 and mu is 0. So that gives a value of 1.95996, and that is our Z value. I've written the Z value on the screen, and we're going to use that in this equation here. Z equals x minus mu over sigma. Now, we've got our Z is 1.95996 equals our x value, that came from the question, the 50.98. So I've got 50.98 minus, now it's mu that we want to find, that's why we're using the Z distribution. And that's all over sigma, and our sigma is 0.5. Now if we go ahead and rearrange that equation, we're going to get mu on its own. So just doing that rearranging, we get mu equals 50.98 minus 0.5 times 1.95996. So when we work that out, it comes to 50.00002, and then I've rounded that to 50.0 to 3 significant figures. Well, what we need to do then, we need to use that to find our probability. So I've set up another normal distribution curve here to explain what's going on. We were given in the question that strips that were less than 49 or greater than 50.75 had to be rejected. So those inside that area are the ones we want to be accepted. Use the normal CD with a lower of 49, an upper of 50.75, a mu of 50 and a sigma of 0.5 to find the probability that it's inside that area there. So again, we're going to use menu 7. This time it's option 2, normal CD. The lower bound that we want is 49 equals upper bound 50.75. Our sigma is going to be 0.5 and the mu is going to be 50. And then press equals. And that should be our answer to part A, 0.9104. So just highlighting there, the probability of 49 is less than or equal to x is less than or equal to 50.75 is 0.9104.